Okay, so let's go through a couple of the features of why this is smart engineering. The first one is that you can see on the side here there's brackets. So that means that there's some screw holes on the side that you can put these add-on brackets on the left and the right to make it open frame and fit within the design of your end caps. So that's the first one. The second one is, notice that across the bottom here there aren't any buttons. Most screens put the buttons at the front or at the bottom, which isn't very smart if you're trying to make it a nice clean design if it's an open frame design. The next one is obviously that it supports HDMI. So it actually has an HDMI plug-in down here, and it has the ability to run other options for older equipment in the field. The other one is that it's 12 volt. So it's a 12 volt supply, which means that it's going to be a readily available adapter if something goes sideways with the equipment, which inevitably you're going to have to replace out what are called the wall warts, the power supplies for these things. So that's why I like this specific design. And I'm sure they can probably put it in any color that you want. And the other one is that it's a 10.1 inch monitor, which means that we can actually fabricate, basically do some 3D printing to put fascia around the front of this. So if we put fascia around the front of it, and on the back, last thing too is you can see that there's little holes here. Those little holes are for VESA mounting, for having it on a stand. So that means that you could order up a stand configuration for some of the end caps that you need to, or you can't just simply use the holes here in the top left and the top right. Now of course also these plates on the top left and the top right come off. So that makes it a nice clean look if with again no power controls or any of the buttons here. You can see the buttons here actually here hidden in the back, which is a nice design. They're serviceable. Staff could get to it, but it means that nobody walking through a location could just come up and start pressing buttons and mess everybody up. There's also enough room on the back here that we can affix our media player, the SAM stick here in the top left or the top right, and be able to run a HDMI cable over and be able to have a nice clean install that can be easily serviced later. Now if I go down through the specs here, there's a couple of other things here. This is not a 1024 by 768. Rather, the resolution is 1280 by 800, which means that it is roughly a 16 by 9 aspect ratio, which means that you can run widescreen nicely on it. The next one is vertical viewing angle. A lot of these lower cost panels are about 150 degree viewing angle. This one's 178, which means that it's a good viewing angle and it's a decent brightness. The other one is that it's actually resistive touch. So the big surprise is for this price point that later on you could actually run a USB cable in between the screen and the media player. There's no guarantee that we're going to be able to build the drivers based off the Chinese software, but we're pretty good at that stuff. So we can work towards actually making this a resistive touch screen. So this is not just a passive panel. Later on, contingent on us being able to do the drivers, we could make this actually interactive. So somebody could come up to the screen, swipe across the panel, and be able to go through the pictures in the video. So that's specifically why I like this this design. And I'm going to be most likely over in Shenzhen on another major project here. I've got a container that's going to be leaving Shenzhen first couple of weeks of January. So I'm thinking about actually taking a retainer, going over to the factory, signing off on the workmanship and the quality, and putting it into the container that I already have. That's going to save you probably between 10 to 20,000 bucks on your project. So that's the screen. That's what I found, and hope you like the video. Happy holidays.